Hello, good morning, good afternoon, good evening, whatever time you're watching this video. I hope your day is going very well because today I'm going to share with you how to balance chemical equations. So what I have on my screen are some examples of different chemical reaction types that we're going to get into and some rules that you need to know. So for the first part of what you all are going to witness here, I'm going to explain how chemical reactions what they consist of, what you need to know before you balance the chemical reaction, and then we're going to get into some of the other example types. So first, let's go ahead and get into it. One of the things you need to know is that when you are writing a chemical reaction, you must follow a set of rules, but these rules don't make sense to you if you do not know them, okay? So I'm going to highlight them as I go along. First thing you want to do is check for diatomic molecules. Now you're probably wondering, what is a diatomic molecule? Well, it's that element that has a subscript of 2 beside it. And as a matter of fact, it forms the number 7 on your, periodic table. So let me go ahead and tell you what those are. And here we go. All right, so let me go ahead and go back through this with you guys. I felt it was better for me to explain how all of this works by showing you. All right, so the elements that you see on your periodic table include, that are diatomic. I'm just going to go ahead and highlight them. There's hydrogen right here, okay? Then you have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And so as you can see, it literally forms the number 7, okay? So those are your diatomic elements that you want to be aware of. And again, they form the number 7. And once you know that, it helps you when it comes to balancing these chemical reactions that consist of those diatomic molecules. Now, step number 2, you want to balance your metals, okay? Your metals are anything that you see over here in purple. So if you follow this order, this is going to get you on the right track of balancing your chemical reaction types. Sometimes the order doesn't always go as planned, but majority of the time it works, okay? It's all about trial and error. So again, you're going to check for your diatomic molecules, which forms the number 7 on your periodic table. You're going to balance your metals next, and then your nonmetals. Your nonmetals are this yellow section over here on your periodic table, okay? So any element that consists of anything that's written in yellow, you would balance that next. For statement number 4, you want to keep your polyatomics together, and I'm going to give you some examples in my next video so you'll know exactly how to do that, because with your polyatomic ions, you do not want to separate them. So a polyatomic ion would consist of something like, let's say I gave you the formula for, magnesium hydroxide, okay? So if I gave you within your balanced equation magnesium hydroxide, you do not want to separate the O from the H. You want to keep the O and the H together as one unit, like you would magnesium as one unit, okay? The next element that you will balance will be your oxygens, followed by your hydrogens and any other elements that you did not balance. Now, none of this is going to make sense until you actually do it. So we're going to explain all of that as we go by and do these examples. But before we get into those, we need to first determine chemical reaction types. Now, there are 6 basic types of chemical reactions that I want you to know about, and I'm going to start off with the very first one. Synthesis or combination. That just simply means you have 2 different elements that forms a compound, okay? 2 or more elements that forms a compound. So in other words, if I give you, let's say, hydrogen, okay, plus oxygen. Well, you know what those 2 form. They form water, H2O. So in other words, it is an element plus another element that's going to form a compound. Now, because of space, I'm going to just abbreviate. So E, in any example that you see me write it out, stands for element, and C stands for compound. All right. Now, if you take a look at decomposition, okay, That means they're breaking apart. That means they're going their separate ways. So whereas synthesis means two elements coming together to form one, think about a relationship. You and your partner forms a union, forms that relationship. However, if things go south and you decompose or break apart or break down, that means what used to be now separates, okay? So here's an example here where you have water that breaks apart into hydrogen and oxygen. So it's basically a compound that forms an element and another element. Now there are cases where it can break down and form an element plus a compound, okay? Now you're probably wondering, can you give me an example? I sure can. Here's one right here. If I give you potassium chlorate, and that's a typical example of a decomposition reaction. This is when you're going to have potassium chloride breaking away from oxygen. So you have a compound right here, which is KCl, plus your element, which is oxygen. Okay? So let's go ahead and move on to this third example. Single displacement. Single displacement says just exactly what you hear it. That means you have one element that's going to replace another element in the compound, okay? So an example of that would be this. Let's say that you have magnesium plus hydrochloric acid, okay? What's going to happen is magnesium is going to replace hydrogen. So you're going to end up with magnesium and chlorine getting together, and then hydrogen is left solo. Now you're probably wondering, okay, so where did that two come from? Well, remember, when the two elements form together, you have to bring the new charges, okay? Bring along the new charges. So in other words, whatever the charge with magnesium plus the other element happens, you've got to include them in the new relationship, okay? So I think of charges like kids. If you break apart, you got to bring them with you in the new relationship, okay? Now, again, hydrogen over here did not have a subscript. But when you write hydrogen by itself or any other diatomic molecule that we talked about previously, then you have to write them with a subscript of 2, all right? Let's go ahead and go to the fourth example. In example number 4, double displacement or replacement reactions are basically compounds plus other compounds forming 2 new compounds. So if you've been noticing here, I've got like AX plus BY, just giving you different symbols of non-element based examples. You can kind of see what happens when they form new compounds on the other side. So X replaces the Y and A replaces the B, as you can see on the other side. So when you have a double displacement reaction, let me show you what that looks like. So double displacement reactions can include things like this. Let's say I have aluminum sulfate reacting with, let's say, calcium hydroxide. What's going to happen is aluminum is going to replace calcium. So in other words, they're going to swap. So aluminum is going to now form with hydroxide. So whatever the charge on aluminum is and whatever the charge on hydroxide is, they're going to partner up together. So this is going to form your new compounds. Same thing with calcium and sulfate coming together. So whatever the charge on calcium was, it's now going to take on that relationship with sulfate. So your new charges come into this new relationship, this new compound. So that is an example of a double displacement reaction. Now, the next example, neutralization reactions. This occurs when you have an acid plus a base. They're going to always produce water and salt. So in other words, think about your stomach. If you've had too many things that are very acidic, you have to take something like a base, like an old school version is Pepto-Bismol or baking soda mixed with a little bit of water. When you drink that, it coats your tummy and you end up forming water and salt inside your stomach. You may have to get, let's say, Tums if you have acid reflux. You may have to get Tums or Malox. So again, another example of this would be hydrochloric acid plus that base, which is typically magnesium hydroxide, and it forms water, H2O, plus the byproduct of that salt, which is magnesium chloride, okay? So those are your examples right there. Now, the last one that we're going to go through deals with combustion. Now, there's a lot going on what I've stated here, but I'm just going to go ahead and zoom in on what you need to know when it comes to combustion problems. Combustion problems are always based on some type of hydrocarbon, okay? It's some type of hydrocarbon that reacts with oxygen to produce carbon dioxide and water. So as you can see, I've got 3 different examples down here, and you can actually look at those and kind of study them. But let me go ahead and tell you, when it comes to balancing those examples, I will show you in the next video how you do that, okay? Now, I did not want to make this video too long, but what I will do is go through some example types so you'll know what to do when it comes to practicing these chemical reaction types. Right, now let's go ahead and switch screens. So right over here, you've got a variety of different chemical reaction types, okay? And what we want to know is what type of reactions I have. So I'm going to go ahead and explain them to you. Again, if you remember, okay, I'm going to put them down below so that way you can kind of see it. A synthesis is basically 2 different elements that come together to form a compound. Decomposition is when you have that compound that breaks apart, okay, into either 2 elements or a compound and an element. The other reaction type that we discussed also was single displacement or replacement, whichever one you want to go with. Tomato, tomato, pecan, pecan, they all mean the same thing, just pronounced differently. So single displacement is when you have a single element that reacts with a compound that forms a new compound and a new element. Double displacement is when they're all swapping around with each other, okay? So AX plus BY is going to now form 2 new compounds over here. And again, these are hypothetical symbols that I'm using, but you get the point, okay? And then the last example is combustion. And combustion, here's something that you need to remember. It will always form, always form carbon dioxide and water. So if you know nothing else, carbon dioxide and water is going to always be on the product side, okay? Now, the last one that I did not go through was neutralization, and that's because you have to know the difference between an acid and a base. So based on this top sheet here that you see 10 examples, we're just going to stick with these 5, okay? So you have 5 different types, and we're going to go into what they represent. If we look at the first example, magnesium plus oxygen forms magnesium oxide. Well, if you zoom on down here and you look for the pattern will help you decide what type of reaction you have. So take a look. Is it synthesis, decomposition, single displacement, double displacement, or combustion? If you said synthesis, you are correct. So that's letter B. Number 2, you have an element plus a compound, forming a compound plus an element. So take a look at some of the examples down here. If you said single displacement, you are correct. Number 3, you have propane plus oxygen forming carbon dioxide and water. Well, based on what I just told you a moment ago, if you see CO2 and water on the product side, that's always a combustible reaction. All right, let's go ahead and skip to number 5. You've got a compound plus another compound forming 2 new compounds. So take a look at the pattern here. Which one does that look similar to for number 5? If you said double displacement, you are correct. And let's do one more, and then I'm going to let you guys do some on your own. Number 7. Isn't this one that I talked about before? You've got KClO3 breaking apart into KCl plus oxygen. What do you think that is? And number 7 is combustion. Now, the ones that I did not do, I'm going to pause the video so that you can try them yourself. When the video comes back, the answers will appear. So I'm going to let you try number 4, number 6, number 8, 9, and 10. All right, try those out. And when you're ready to see the answers, then you can hit the video and hit play again. All right, let's go ahead and get these answers on the screen. All right, so these are your answers. Okay, in the next video, I'm going to show you how to balance these chemical reactions. All right, so stay tuned for part 2 of this video. How do you balance these reaction types? Let's get into it.